So, what is up, bro? And here I am with another idea. Well, actually, this is not a failed idea. Maybe this is not even an idea. This is just kind of a thought that I'm playing around with, and I don't exactly know if this can become a real hypothesis. I actually don't know how to like put it in front of a professor so that he doesn't think I'm just going crazy. And this one's gonna be about Heisenberg's uncertainty principle. Now, I'm not saying Heisenberg's uncertainty principle is wrong in some way, but it's incomplete or maybe even misinformation. So, let me tell you my thought experiment first, then I will correlate it with the Heisenberg's uncertainty principle. Suppose you have a blind scientist, and there is a room where balls just keep on floating around. They collide with the system, they collide with the walls, and there are multiple, we don't know how many. So the room is filled with balls moving around, colliding with each other and the wall, and the system is kind of unknown. It is kind of not unstable, I would say, but the system is quite explosive, literally. So let's suppose this is a ball. Let's pretend that this is not a ring, just a spherical disc. So this is a ball, and balls are constantly moving around in the room. And there is a blind scientist. He wants to know the exact position and momentum of the balls moving. And the only way he can find out the position of a ball is to strike the ball with another ball, so that the sound produced of the collision gives me a kind of reference to, okay, this is where the sound came from, so this is the exact position. I can do the calculation, I won't need to explain it as much to you. So basically what I'm doing is, if there is a ball moving around, suppose this, so I can strike it. Fuck, I missed. So I can strike it with another ball of the same size. The blind scientist, not me, the blind scientist can strike the ball with another ball of almost the same size, and the sound of the collision is what tells the scientist what the position of the initial ball was. But there is a dilemma. Thing is, once the ball hits the another ball that I want to know the position of, now because of that collision, there is an increase, or I don't know, decrease in energy of the system. So the direction or velocity or momentum of my initial ball is unknown now. So initially, if I know that my ball was moving in the left direction and I strike it now, so I do know the position of the ball now, that it is here. But because of that collision, I don't know where the ball moved now, and I can't know the exact position of. And using this hypothesis, using this as a base, our blind scientist happily concludes that it is not possible to know the exact position and momentum of the ball simultaneously, which is hilariously true for him, but not for the system. The thing is, yeah, sure, the way you are measuring the position of the object, it is not good enough to measure the both momentum and position simultaneously. It is not good enough. Your method is not good enough. Your method of observation is not good enough. That does not mean that the system itself is undeterminable. And we know it. Like, we have something called light, and we can see the balls moving. So I kind of can know this because the size of the balls are quite large, so they don't get affected by light striking them. So I can effectively know the position and momentum of large balls just colliding with each other in a closed room. I can know the exact position and momentum of each of the balls because I have light. But the blind scientist can't, because his method of observing the position of the ball is rigged. It's not good enough. His method is not good enough. So, based on his method, I don't think it is viable for him to conclude that the system itself is undeterminable, or there is probabilistic shit in the system. You can't exactly tell. There are only possibilities. The balls are in kind of this probability that a ball is everywhere and nowhere at the same time. That is just plain bullshit. And this is what exactly we are doing with the Heisenberg's uncertainty principle as well. The thing is that the objects, like the quantum objects like electrons or quarks or whatever, whose position I want to know, the only way to know their position is by striking them with photons, for example, say. So when I strike them with photons, which are almost equal size of an energy of the electron, they obviously are going to change the energy of the electron. They obviously are going to change the momentum of the electron, just like in our striking the ball with another ball case. So that just means that my method of observing is rigged. It's not good enough. That doesn't mean that the whole system is just undeterministic. So yeah, this was something I wanted to convey. And I think Heisenberg's uncertainty principle is just, it's not wrong, but the conclusions it forms, I mean, it is saying what is true from our perspective, because we don't have a better method of observing than light, than just striking other things with light and observing their position, which is just like the blind man's way of striking things with bigger objects and listening to the sound where it's coming from. That is not. But if I come up with this shit that the whole system is undeterministic, that is me just drawing wrong conclusions from an experiment. That is not true. It just means that my method is not good enough and we need better methods to observe. So yeah, this was my rant on quantum mechanics, kind of, and let's see where it gets us. Maybe I think of a way to explain the same thing to my professor so that he doesn't think I'm crazy, and maybe we can write a research paper on it, but who knows. Don't steal my idea. And keep thinking, keep having fun.